Swayam Prabha. Digital India. Educated India.
Okay, let's get started. See, today we are discussing the chapter 2 of the handbook in details. Now, this chapter is more for the conceptual design of precast concrete buildings. First, we will be talking about the overall structural systems. What is meant by a system? System is a collection of components to serve a certain purpose. We have systems in our human body. Now, this system is to transfer the load. First, we are talking about the gravity load, which is there every second. And next, we will be talking about what are the special, maybe subsystems for the lateral load resistance. Yesterday, I have already covered in the handbook. Okay. Today, we are going into more details. Roofs and the floors, there can be varied types, and these are subsystems within the overall building system that we shall see. Next, we shall talk about the components, that what are the components which make up the system. And as I am saying, here lies the ingenuity of the precast industry as compared to conventional cast in place. And I can guarantee you whatever you are going to see today, you haven't seen in a conventional course. Okay. Roofs and the floor units, the wall units, foundation units, and units for miscellaneous applications. Overall structural systems. So, it is always nice to have this type of tree structure to have a clarity in mind that how do we classify different types of innovations. Broadly, we can say that these precast systems fall under the category of frame system, which is also common in cast in place. Okay. See, if I look into a traditional construction from the ancient times, we had both wall system as well as the what is called the column, or the typically they call it post and lintel system. Today you saw the picture of the Pantheon. The Pantheon is a wall type structure, but in front of it, that's a frame type of structure. That means the concept is there from time immemorial. But now we are studying this with reference to precast concrete. Now, within the frame system, we are classifying, this is the way we classified in our handbook, and most of this information I got from Dr. A. Ramakrishna. That's why I owe whatever I have written in this chapter, I owe to him. Okay. This classification is more for how to design. Okay. First is the low-rise portals and frames. Okay. Where the earthquake will not be of much of importance, whereas wind can be of importance. Next comes the multi-storied frames, where both wind and earthquake will be important. Now, there is a third system which is like mimicking the flat slab system. Now, this is not very common in our country yet. I myself am yet to see a building where you cast the slabs in the ground, lift it up with jacks, and just rest it on columns, maybe on column heads, which is like a flat slab system. Okay. This is a lift up construction, but I will not be talking about this since I haven't seen any example in this country. The second type is the wall type system. Sometimes it is called large panel system. In different countries there is different terminology, which is now becoming very common in our mass housing. Third is the 3D volumetric system. Sometimes it is called cell system, box system, which is also becoming common. And the fourth one, the hollow block system, although it is made up of precast units, typically it is classified under masonry construction. Okay. I will be briefly mentioning about this. The skeletal frame system, when is it suitable? That means in the conceptual design, when you sit across the table with an architect, you should have this in back of your mind so as the conceptual design is done properly. This is suitable for buildings that require flexibility in usage and remodeling in the future. Please note, a building is built for 50 years, but every 10 years there may be a change in the lease. I am saying office space. And once a new company comes, they may refurbish. And once they want to go for refurbishing, if you have too many load bearing walls, you cannot refurbish. That's why you should have more column free space. Okay, next, no visual obstruction due to walls, which is the requirement from the architectural side in an office space. Relatively independent of the mechanical, engineering and plumbing systems. That means today the building was not air conditioned, and now if it is air conditioned, you should be able to implement it. Flexibility in the selection of facade cladding. That means what is the facade? Facade can change. To give example, the IIT Madras Research Park, the phase 1 building, which is now the block E, I think, the facade was changed because the earlier facade was not working properly. Okay. Individual units are suitable for production, transportation and erection. We have already highlighted the importance of this. As a designer, you have to be aware that it's an industrial product, how it is being produced, how to bring them to site, and how you are going to erect them. However, you may need supplemental lateral load resistance. We will be talking about that in the systems for lateral load resistance. Now, where are the examples? School buildings. See, this project is the one which was taken up in Gujarat. Several school buildings were made in a very rapid mode construction. What they did was they had some columns, they had like a beam, over that the roofing elements and an enclosing non-bearing load elements. Of course, some of them failed during the earthquake. That's a different story. On the right hand side, we are seeing something else. This is an industrial building. Now, these types of building can be used for heavy engineering or chemicals. It can be used for railway yards, and they compete with the steel. Now, which one is better? It varies even from time to time, place to place. It's a very dynamic thing. Whether precast is better than cold form steel, and sometimes they can go for a mixed construction. Okay, you can have precast columns and a cold form sheet roofing. Now, here what we see is that in this building, which is a heavy engineering works in Hazira, here you can see the nice way the portals have been placed. Over the portals there are purlins, and over the purlins there is a roofing. And there is also a provision of the daylight system. Next, commercial buildings, wholesale outlets, departmental stores. Now, this type of malls, they have brought in new architectural possibilities, along with that the structural design and construction possibilities. Okay. Convention and congregational centers, airport terminals. Look at this beautiful picture. This is the Bengaluru terminal, where these are made up of shell units. Again, the units I will be coming later. But you can see how nicely the daylight scheme has been introduced. Okay. And all this needs quite precision in the design. It's not like just put a slab, put a roof. It's not like that. Okay. Storage facilities, industrial buildings. If you look into this building, which is in Thoothukudi, which is Tuticorin, here you see that these are rafters. I will come to this component of the rafters again. Over the rafters, there are purlins, which are trussed purlins to increase the stiffness. And over the purlins, there is a roofing element. At many locations, there is a daylight provisions. On the right hand side, it's a similar type of structure in Satna. Again, it's an A-frame with, we will talk about the joints. It is very important that you cannot just construct an A-frame just like that. You are again trying to make it a jointed system. Where should the joint come? We will discuss. The next type is the multi-storied frames. Today you saw the construction of this, which Professor Jaya was showing, the Chennai Silk building. The Chennai Silk, those who are not from Chennai, just to tell you, it is a major silk uh, you know, outlet, but they have also gone into the construction, and their construction wing is called Timage Precast. Okay. Now, the multi-story frame buildings are suitable for institutional buildings, which can be educational or hospitals. Even commercial buildings is fine because you get open column-free space, shopping complexes, parking structures, and stadiums. Now, this particular project was under the Lighthouse project, which is under the Global Housing Technology Scheme. I want all of you today, when you go back to your dorm, please go to the site of GHTC. See, as a faculty, as an industry person, or even as a student, don't just restrict your knowledge to some textbooks. See, read company brochures. These days, these are readily available in the website. See how the government initiatives are being taken. And under this GHTC scheme, which comes under the broader umbrella of PMAY, which is the Pradhan Mantri Awas Yojana, the urban group. Now, under this Lighthouse project, they had selected 6 places in India where they are demonstrating the different possible technologies for mass housing. And one of the possibilities is using this framed type of construction. And this was gone to one of the leading group, which is the BJ Shirke group, whom you will be listening to them in the last day. And you can see what they are doing is, first they will be putting a pad foundation, then they will erect the columns, and today Professor Jaya said that it is a hybrid emulative construction. That means there is a component of mechanical systems, some inserts are there, but we are also having on-site concreting. In this way, we can ensure durability and ductility. Okay. Now, this frame members are rising up, and then you will enclose the space, maybe just lightweight block work. These days, the aerated Yarokon blocks have become very common, or fly ash bricks have become very common in place of conventional bricks. Okay. And this project was in Chennai, which it was inaugurated by the Prime Minister himself. Some other projects by Precast India Infrastructure. This photograph on the left I showed yesterday. I talked about this in the context of the connections, and here also you can see that they are putting these beams on the corbels. They are keeping the provision of on-site concreting, and like that they are going for an emulative construction that at the end you just analyze it like a monolithic cast in place construction. On the right hand side is the World Trade Center. If you go to Pune, please visit either BJ Shirke or Precast or even both. Both of them are leading precast manufacturers in the country. I happened to go to this site when I visited the factory of this Precast India. This is a data center building. Now, these are new age type of buildings where you need huge space for all the equipments related with data storage. And here also they have gone for, see, these are the beams through which they will pass bars and they will introduce continuity. That means originally they are like simple members, they are supporting it on corbels, but then they are introducing continuity. Going to stadiums, again yesterday I showed this photograph that the stadiums are a very good application of precast concrete, and if you visit a stadium you can see the exposed structure. I had taken our students to see this Jawaharlal Stadium in Chennai, which is just next to the central station. This was, as Mr. Raghavan said yesterday, that it was made in a rapid pace before the South Asian Federation Games in 1993, and most of these components are all precast. Next comes the wall type system. That means we finished with the frame type. Now we are moving to the wall type. Now when is it suitable? It is suitable for buildings that require close partitioning of space. It is just the opposite. In the frame construction we said we need open space, but now here we are saying that we need to have close space. I cannot go on doing block work in so close space, that will be very manual intensive. Here we can provide smooth surface ready to paint or paste wallpaper. That means plastering is getting outdated. If you can make precast wall panels smooth enough, you may just have to do some color wash or maybe put some wallpaper. It can accommodate insulated panels for thermal comfort. These are all in special type of, if you go for say a food storage building, they have a certain type of requirement, cold storage. There these are required, that why not to make thermally insulated wall panels, and they provide adequate lateral strength and stiffness as compared to a frame building. However, they need tie reinforcement for integration. This is an important aspect of any precast building, that we need tie reinforcement to make sure that they stay together during any vibration. What is another problem? A problem is limited flexibility based on presence of non-load bearing wall panels. The wall panels, the way you design, some of them can be load bearing, some of them can be non-load bearing. Even what is meant by non-load bearing? Say today your grandpa is building a house, okay. They will make a thick brick wall, make the roof, and then if it is a one story I am saying, and then they will make some partition walls. The inside partition walls are non-load bearing. You can knock them off. However, you cannot knock a load bearing wall. That means any change, you cannot just do it arbitrarily. This type of wall system is suitable for residential buildings. It can be low-rise bungalows if you get a project where there are multiple houses coming, or mid to high-rise apartment buildings. This is the technology which is been used by the slum clearance board. Now, I feel that in this course we should have members from the slum clearance boards, the housing HUDCO, and the other organizations which are involved in mass housing. Unfortunately, what has happened is that these groups are now outsourcing the design to companies, and their engineers do not feel the need to get continually educated. They are more into administration. But this type of courses is like a tonic, that it energizes you, okay. It tells you that what are the possibilities. You may not design yourself, but at least let you be aware, okay. Now, I had the opportunity to visit this particular project in Bhoiwara in Mumbai, which was taken by this Mumbai Slum Clearance Board, and it was an eye opener for me that how that even for economically weaker section, this technology can be adopted, okay. It can also be adopted for other types of dwelling units like dormitories, hostels. That is what we are targeting. We are planning this Vaigai hostel in our campus. Hostel needs what? Like in IIT we give the privilege of one room, one student. That means we need to have closely spaced. Now making walls that was possible in the way 60s, but now things have changed. Now we are planning to go for this wall type of construction, and also hotels. Yesterday I showed this picture of the triple IT Sri City. This superstructure was built in 2 weeks, okay, 5-storied building. On the right you see the SRM University in the Trichy, and here it is a mix of wall and frame elements. That means it is not that only one type will be there. Even in a frame type building, you can have the walls in the core areas. Next comes the 3D volumetric system. This is suitable for enclosed spaces, can accommodate fittings and finishes before installation. This what yesterday was shown in a figure, where we are now using the term prefabricated construction. Prefabricated is one step ahead of precast. That means it is not just the concrete walls, you are also having the washroom fixtures, the kitchen fixtures, and this is the way technology has advanced in countries like Singapore. Okay. It can be used as a subsystem that within a frame building you can use this volumetric system in certain locations, and it provides adequate lateral strength and stiffness. However, it needs tie reinforcement for integration, and here also we have limited flexibility. You cannot go on changing the the usable space. These are used in hotels, studio apartments, justice facilities, means jails. As a subsystem, it can be used in bathroom pods or kitchens, closets, balconies. This figure I showed on the right side, here you see that it is not a planar anymore. It is in 2 dimensions. I would say in 3 dimensions. Plane is a 2 dimension. This is a 3 dimension precast system which is being lowered down. Now, there is another project under this lighthouse scheme which was undertaken by SGC Magic Crit, which has used this type of construction. And the photo I put on the right yesterday in a hurry, it is a wrong photograph. That is actually from the Chennai one. I skipped the photograph on the right. You can mark that that is not the photograph of this project. That these pods are stacked, okay, and then these houses are being made. Now, this is by a company which is doing excellent work. I would ask the L&T, that Water and Effluent Treatment Group, to stay connected with Mr. S.J. Vijay. He is Bangalore based, brought the technology from Singapore. His company, which is the Home Mission India Private Limited, they have taken a special venture for housing, and you can see how these are being constructed. Now, what I visualize for the precast water tanks is this system. Now, I had the opportunity to listen to Mr. Vijay last, I think somewhere in November or December, when Indian Concrete Institute felicitated him. He will talk about all the machineries that they are using, what is the planning they are doing. I am not a specialist in this particular field. That means, if you are interested to adopt this technology, and I would strongly suggest, please learn from him how the technology is being implemented, and then try to implement this in your water tank project. The hollow block system, which is also called the concrete masonry units, here these precast blocks are made with holes inside, and then these blocks are stacked, reinforcement is placed through the holes. There can be reinforcement even horizontally within the beds, and then you pour grout or concrete. It can have nice lateral load resistance. Typically, they are used for commercial buildings and residential buildings. In US, all these big shops like say Walmart or Kmart or IKEA, they are departmental stores, which is actually a very high storied, one-storied buildings. They typically make out of this type of concrete masonry units. They are suitable for vertical load bearing, also lateral load resistance, and however, they need reinforcement for integration. See, each technology is suitable under certain type of application, that you have to be aware. Next, coming to the systems for lateral load resistance. If I look into the portals, let us try to understand how do I generate the lateral load resistance. That in a portal, yesterday Professor Leon Liberato pointed out that we need to fix the columns. They are like vertical cantilevers, okay. And in order to fix it, we use a type of foundation which is called pocket or socket foundation. Now, these columns, over that you are placing the girders. Over the girders, you can place maybe purlins and the roofing elements, and then you do a screed concreting to integrate this precast roof members to provide a diaphragm action. That means, during an earthquake, this whole thing should move together and mobilize the supporting columns. This is a schematic sketch to show what are the components like beams, columns with a corbel, foundation, purlins. Okay. Now these are suitable up to a certain story. Beam to column connections are assumed to be pin jointed. That means this is what comes in the analysis. When you do the analysis, yesterday I showed the bending moment diagram, that it is the columns which are taking the moment, not the beams, subjected to sway, and hence if the sway is more, you have to provide some bracing. Okay. No one is saying that you should not put bracing. Okay. I did not show, but bracings are also possible. And diaphragm action at the roof provides the integrity. This is the type which has been used in the industrial buildings which I had shown. Here these are all A-frames. It is like a gable structure which gets the framing action from the moment resisting rigid joints. Now the joints are not at the joints per se, their joints are at the inflection points in this rafters. And here you can see how you can conceptualize that, how will I construct this frame in a factory. That means there will be an A frame at the top, then there is a bottom piece, and in the bottom we do not need a pocket foundation, it can be a pad foundation. Okay. Now over the A frame you will be having the purlins and the roofing elements. These are sub-assemblages of rigid beam to column joints. The connections are at the locations of zero moment under gravity loads, and simple pad foundation is adequate. Now coming to the multi-storied frames. In the multi-storied frames, if we are having rigid beam column joints like a monolithic cast in place construction, then the framing action itself provides the lateral load resistance at least up to a certain height of the building. Beyond that you may need shear walls. Now here, this is what Professor Jaya was saying today. The most common in our country is that cast the members separately, beam, column, it is easy to transport, and then at the joint region you do the on-site concreting and make it monolithic or emulative. The other option is that you provide corbels, which was also shown today, support the beams, and then you can have some cleats and you can have some bars connecting them. You can, like that, you are trying to have some continuity. And this system of course requires lateral load supporting system, because we are assuming the beam to column to be pin jointed. It is like a seated connection. Options of self-centering are possible. Now I have seen, at least in the university level, what they are doing is they are trying to introduce this post tension members, post tensioning strands from end to end, which can avoid the use of corbels and also provide this self-centering action with some dissipating elements of mild steel. Dual system means it is a mix and match of the frame system as well as the wall system to get the benefit of both of them. That means in the office space we are having the frame system where we are having large column free space, whereas in the core area we are having the wall system by which we are getting the lateral stiffness. If you look into the design of high-rise buildings, this is what is adopted, high-rise buildings for office purposes. Now here of course we have to be careful that how we design the load bearing walls and the non-load bearing walls. That gives the option of refurbishment in future. If I am having load bearing walls all throughout, like a corridor and offices on the two sides, I cannot knock them off. Whereas if I am just providing load bearing walls on one side and then I am having some partition walls to make my offices, obviously the partition walls can be shifted around, and if in fact that is done, even we have done this in our classroom in structures lab, that where we wanted to increase our classroom, we knew that this wall is just a partition wall, we knocked off and moved to the next bay. Coming to the roof and floor systems, what is the difference between roof and floor? Floors have to be flat, okay, whereas roofs need not be flat, and that is where we can have some ingenuity. In the roof systems, we have already seen that we can have purlins or trusses or arches, we can have shell units, and we can have folded plate units. Now, in these school buildings in Gujarat, there were conventional just slab units placed on beams. On the other hand, this is a zoomed in picture of the shed in Tuticorin. Here you can see that these are the trussed purlins over which the roofing elements. That means, all this constitute the whole roof system. See the beauty of these industrial buildings. I cannot overemphasize what Larsen and Toubro has done way back in the 1970s, when there was a boom for this type of construction. Okay. These are like stiffened members, okay, roofing elements which are supported on trusses, and some of these trusses were even pre-tensioned, the bottom cords, and you can see how elegant this roof system looks. Shells, this on the left side is an go down. So, you may think what is there in go down, but let me tell you, there has been wonderful construction, even innovative construction way back in the 1930s by Eugene Fresinet to make airport hangars of this shape. Okay. You see how elegant it looks. These arches are precast, the roofing element is precast. Okay. On the right side is a zoomed in view of the Bengaluru airport terminal building. You can see the nice shells. These are not plastered, these are just form finish. Folded plate units. The figure on the bottom I had showed yesterday. We are proud of it that we have such a building in our facility where we can take our students to see the roof. On the left, you can see the folded plate units with nicely incorporated the daylight scheme. The left is the shell structures. It is the convention centered in the structural engineering center, and shell sky is the limit. People can come with wonderful, there can be full course on shell, seminars on exotic shell constructions, and shells are typically precast or they may be cast in place also. The figure on the right is our student activities center. Whoever is staying in Taramani, you can just walk down and see that facility where we have our students playing badminton. Here you can see this roof was made in the shape of tent, okay, and this was made using precast elements. Coming to the floors can be classified the way we teach in reinforced concrete the slabs as one-way slab, two-way slab. Similarly, the floor can be classified like that. Okay. Let us see the photographs. Okay. Before that, what are the components of a floor? There are floor units which can be either untopped or pre-topped. Pre-topped means the topping is being done in the precast factory itself. The spandrel beams are the supporting beams at the edges. There can be intermediate supporting beams, and there will be some reinforcement to generate the diaphragm action. I will come to the sketch. Now, this is a schematic sketch of how to design a diaphragm, that we are making the floor jointed, but they have to be integrated to act like a monolithic member to mobilize the vertical lateral load resisting system. Since if the aspect ratio gets large, it tends to bend in plane outwards, and hence they will try to separate out. We need to provide reinforcement at the two edges. Please note, earthquake is a dynamic load which is reversible in nature, and these reinforcements are called the chord reinforcement. Okay. If I am using pre-topped elements, then I should connect these members with some stitching. For that, I need some embeds within the hollow core slabs. typically this technology is not used in our country because it needs a lot of precision. Whereas in our country they will be going for a reinforcement mesh and some concreting. If it is properly designed, see again there you can take advantage of this topping. The topping will act like the diaphragm, okay. But if you say that I want to make it composite, that I want also the panels to act as a diaphragm, then you have to put some shear connectors. Hence in our country we go for what is called a non-composite design of the floor diaphragm. If I am having shear walls which is only for a certain length, I need to connect the rest of the floor with the shear wall, and that is called collector or some drag reinforcement, and I have to have proper anchorage with the shear walls. Now with this I am ending the different systems. What did we cover? We covered the overall system for carrying the gravity load. I need to understand the load path. Next, the lateral load system, okay, that how I can generate the lateral load stiffness as well as the strength, and finally the roofs and floors, how they can be made up of. Next, I am coming to the components which make up this system. The beams can be of varied cross section. Now, whatever I have shown, it is from my teacher's notes. These are just schematic in nature. Please note, actually they will look much more involved, but anyway in our calculations we can simplify them. The rectangular ones are typically used for small members like purlins. The members can be slightly tapered for the release of the formwork. We can have flanged members to economize the amount of concrete section, and we can have I type of members. If I am going for pre-stressing, I need a bottom bulb to provide the strands. Now each one of them has their benefits as well as certain deficiencies. Now, which one is applicable where, that you should be aware. I am skipping the details in short of time. Now here there are the beams which are having ledges. That means they are supporting either hollow core slabs or maybe from one side or two sides, or the ledge is at the bottom where they are supporting some double T girders. Now if they are supporting members only on one side, please note there will be a torsional effect. I need to have some restraint at the ends to carry this torsion. Other variants, we can have a girder with conduits. I will show photographs of that, or a provision for gutters for the roof. See the one in the middle with this box type of section, this is what exactly is used in box girders. The box girders in bridge is a much larger version of this. Coming to the column units, we can have corbels to support the beams, or we can have some stepped columns like haunches, or we can have billets which is like structural steel inserted to support the beams. We can have shapes to support the girders at the top, and this is a spandrel column which is having a ledge to support a wall element. This is a Y-shaped column. Let us see some photographs. Now this is the photograph from the Timage factory I visited in Tirupur. Here you can see these are the ledges. Over that they are the shear connectors, and when they will be putting the hollow core slabs, they will be having a structural topping where the beam, the slab will get integrated. They were actually extending their factory by their own products. That was nice to see how they are using their products to construct their factory. On the photograph on the left, you can see a girder with a U-trough, that is for drainage. On the right, this is a very special purpose girder. Please note, this girder is having a conduit and also voids. This is for air conditioning ducts. That means the air conditioning duct has been concealed inside, okay. And these girders are being supported on Y-shaped columns. That means this is a special purpose building for the textile mill where the temperature and humidity has to be controlled. Coming to the roof units, we have already seen the roofs which can be consisting of purlins, girders, trusses, arches, shells. The roof girders can have a slope. Okay, this is Dr. Liberato already said that they are calling it a thatched beam, or we can say like a saddle type of member with a camber. Okay. Trusses, the figure on the left I had shown yesterday, that these are, the bottom chord is pre-tensioned. On the right photo also I showed yesterday the Kanthirava Stadium, where they are using these arches to make the roof. Shells, on the left is a hyperbolic paraboloidal shell unit used to make the roof. On the right side is the folded plate units. Now, in the handbook, there are tables like this which have been compiled in Larsen and Toubro of all their projects earlier, which gives an idea that with what type of truss is suitable for what type of span, what type of loading, that has been recorded. Now, it was nice that the L&T has recorded this for the benefit of the future, okay, so that you do not start everything from scratch. Coming to the floor units, let me go to the sketches directly. The ones which has become very common are the hollow core units. There can be different types of voids. The biaxial hollow slabs has come to India. I do not know how much it is being used. Here plastic voids are inserted in a precast section which is called a filigree element, and this is the two-way version of the hollow core slabs. The ribbed slabs are the like a stiffened slabs. Double T's are the larger version of the ribbed slabs. Even waffle slabs can be precast, and composite means that we are designing the slab, precast and the cast in place together to act as a composite roof. This is what I had shown yesterday, the hollow core slabs. On the right side is the two-way roofing element used in Sri City. This is how they are integrating the hollow core slabs with the supporting beams by stitching elements. This is where the ribbed slabs have been used. This is like a dormitory for, it is like a dharmashala, means it is for the pilgrims to stay. Double T units used in the industrial buildings. In US, these are very common for the parking garages, and we also see some of this in our parking garages of the malls. Okay. Wall units, it can be load bearing, non-load bearing, special purpose insulated or textured. This is one of the photos I had shown yesterday, that these wall elements, how they are connected with each other through the loops. There can be window openings, there can be some brackets to support the slabs, and some of this you are going to see in the factory. How they are lowered down. Please note, these days all this, yesterday I was talking about the information technology, all this precast, this is like putting up a Lego toy. As a children you may have played with this, how to make a building. All these components are RFID tagged, and they have to be stacked properly, okay. And during lowering down, the dowel bars have to go through the ducts. This is another photograph I showed yesterday, that for the Jamshedpur project, how the wall elements were made. These are the non-load bearing panels used in the Gujarat school buildings. Now, these are the textured finishes. See the wonderful finish. This is like a beer bottle type of finish. This is not possible as cast in place, okay. That means precast facade panels have been put to give this texture. On the right side you see this corrugated finish. Coming to this building, I had the opportunity to visit their factory. This is the Infosys multi-level car parking in Pune. If you go to Pune, please visit this building. Unfortunately, what happens is, under the Indian road context, the outside roads are so congested, you do not get the opportunity to see the beauty of the building. Had there been a lawn in front of this building, it would have been looked much better. Now, here what they did was that here you can see the frame members. Over that, they had these provisions of fixing these facade elements. And once the facade elements have been placed, high precision engineering. Okay. You can ask Kapilesh Bhate to speak about this particular project. This got the award from FIP, which is the European Concrete Union. Coming to the foundation units, I talked about this yesterday, that the shallow foundations can be like pad foundations, which can be used for when I don't need fixity at the bottom, whereas if I need fixity at the bottom, then I should be going for a pocket or socket foundation. And we also have the pipe. Talked that what are the beneficial effect of this pipe, that they are high marine environment. Miscellaneous units, there can be service trenches, boundary walls, grandstand units in the stadiums, city and other industrial structures. Like these are the trench units which can be used. These days we need more and more of this in the type of buildings that we are having. In data centers you will be having lots of this. These are the boundary elements. I showed the photograph yesterday. This is the boundary of our extension campus in Thayur. These are the stair elements. This is the inside of the Kanthirava stadium. Please note, that means apart from the roof, substantial amount of precast has been done, and this project was championed by Mr. Sundaram, who was also felicitated by FIP. Okay. On the right, you see the grandstands of this racecourse stadium in Madurai, how nicely, elegantly done. Industrial structures, conveyor belt housing, you can see even its industrial structure, we think that they are very dirty. Need not be. It can have also an elegant feeling. Okay. Pipe rack structures. See, many of our students joined this type of heavy industries, and the type of structures you have to design is this, not what we teach in our conventional beam design, column design, not like that. You have to get to know the specifics of this type of structures in the specific industry. In summary, today we talked about the systems. First, the systems for the gravity loads, next for the lateral stability, floors and roof systems, and then understanding the components that make up the systems.